Good morning. I hope everyone can hear me. Can you hear me? Does it sound like, can you see my desk? My hope is that you can hear me and you can see my desktop. Is that the case?
Yes, it is
Yeah,
the
yeah.
case.
Okay, great. My Zoom client decided to update itself right when I opened the meeting. So that's why I'm late. Sorry about that. It took a couple minutes for it to decide to you know, r- change versions. I tested it yesterday and it was fine. And then today when I started up, just when I started the meeting, it said it had to be updated. Okay. So, let me see. Hopefully most people will be here soon. I think there's still some people joining the. What we're going to do today is pretty much use. I'm going to be sharing my desktop and using my desktop just like I use the projector in class. So we'll just do some examples using the Java Visualizer, and I have a little whiteboard I can kind of draw on. So it'll be pretty much just like the way we do class. I'll be showing you my desktop and I'll be doing the work on the desktop. And um, as we go along, if you have any questions, please just speak out loud. Like it's when I'm doing this, it's kind of hard to pay attention to the chat and to look for anyone who uses the little raise hand feature. That doesn't work very well. So if I'm talking and you have a question, just unmute yourself and interrupt me and just say your question because I probably won't notice anything that you put in the chat, and I probably won't see if you raise your hand. So it's perfectly okay to just you unmute yourself and just interrupt me if you have a question. Okay. And what we're going to do today, for an hour or so, we're going to do like a class session, and then we'll do the lab more or less the same way that the labs are done anyway. Usually, the lab assignment is in your Zybook. So after class, you can just open your Zybook and go and do in the lab. I'll stay in this uh, Zoom session. I made it like a 4 hour Zoom session, so I'll just stay in it, and if someone has questions, they could just ask me questions from the Zoom session while they're doing the lab. And as far as I know, that's about the only way we can do it. So you'll do the lab just the same way you would normally do it. You just open the Zybook in your browser, and you'll do the home and do the programming assignment in the lab. When you're done, you can just submit it, and then you'll be done. And but if you want to ask me a question, and like I say, I'll just stay in this Zoom meeting for the whole time. And I think you can leave. Does anybody, can you just leave it and rejoin it? Does anybody know? I'm not even really positive. I think you can just leave meetings and rejoin them if I leave it open.
If
Everybody
they're
else know?
open, you should be able to do that.
Yeah. I scheduled it as a 4 hour meeting. So if I keep it open, you should be able to just, if you leave it, you go do the homework assignment, you have a question, the link to it is on the course website. Okay. So, you should be able to just rejoin it by, I guess, using that link again and just joining back into the meeting. Okay. Okay. So, we're gonna. Okay. Does anybody have any question to begin with? Is there any question about what we're gonna do today? Let's see. Okay. All right. So, we're starting a new chapter. We're gonna start talking about a new chapter now. So the chapter is this thing on inheritance. Okay. And we're going to be talking about this idea here. Okay. So the inheritance is one of the more difficult things to talk about in object-oriented programming. So we're going to try to do lots of examples and go through this slowly. It's where object-oriented programming kind of becomes a little bit more abstract. Okay. So here they have a picture, and this is the idea is that when you talk about vehicles, there's different kinds of vehicles. So a motorcycle is a vehicle, a car is a vehicle, and a truck is a vehicle. And sedans and a sedan is a car, and an SUV is a car. Okay, we want to turn this. It's kind of a trivial idea. I mean, everybody knows this, but we're going to turn this into a programming idea. We're going to have a way of defining a car class, or let's say, we'll start with a vehicle class, and then we'll define a motorcycle class, a car class, and a truck class that's somehow tied to the vehicle class. Main idea is that a vehicle, a car, a motorcycle, and a truck share things in common because they're all vehicles. You don't want to write code 3 times, once for car, once for motorcycle, once for truck, that's the same because it's what they have in common as a vehicle. So this inheritance idea is a way of saying, I'm going to write the vehicle stuff once, then I'll write what makes a car different from a truck. I'll put in the car class, what makes a car different. Well, I'll put in the truck class, what makes the truck different. But what they have in common will be in the vehicle class. Same thing down here, you'll put in a sedan class, only what you need to make sedans different than cars. And you'll put in an SUV class, only what you need to make it different than a car. Hey, now one of the troubles with learning inheritance is that people use examples like this, and then they don't turn them into code because this example would be kind of hard to turn into code. So we have to try to find examples that are a little bit more codable, that can make a little bit more sense. So here's a small example. Okay, a savings account class. Okay, okay, what's a savings account? Well, you have to have amount of money in it, so we call that the balance, and it has an interest rate. You can deposit now. Remember we've said that classes represent objects that store data. Okay, so a savings account has 2 pieces of data, how much money is in it and what its interest rate is. And then you have methods that let you do things to that data. So somebody could deposit money in their account, they could withdraw money from their account, and they could compound interest. I didn't write the formula for compound interest, but the bank would call this, say, once a month, and it would take the interest rate and make a deposit in your account based on your interest rate. Okay, so this is what a savings account does, okay? And this is what data it holds, okay? Now, what about a checking account? Okay, okay, a checking account would hold a balance, okay? You could add money to your checking account, you could withdraw money from your checking account, and you could write a check on your checking account, okay? Now, if you look at these two, I can kind of put them side by side. They have code in common. Okay, if you put them side by side, you can see that they both have a balance. They both allow you to deposit. They both allow you to withdraw. And what the bank savings account does is it compounds the interest because it has an interest. The checking account, well, some banks give your checking account interest, some banks don't give your checking account interest. Okay, I'm going to pretend that this bank, the checking accounts get no interest, which is is it not that uncommon. In a lot of banks, the checking account doesn't get interest. But you can write checks on your checking account. Writing a check is a way of letting somebody make a withdrawal from your account. It's a way of giving someone permission to make a withdrawal from your account. Okay, so this is duplicated code over here and over here. So why should you be writing it twice? Okay, so inheritance is the way of dealing with this kind of thing. So what we're going to do is here's a little picture. Oh, I don't have a picture for this one. I thought I did. Okay. Um, we're going to turn this into an inheritance tree. Yeah. So what I mean by that is we're going to have a tree where we're going to have a bank account. I kind of write sloppy here. Okay. And then there's going to be 2 kinds of bank accounts. So this is like the tree that was in the book. This is like this tree here, but it's going to be a simpler tree. It's going to have bank account at the top, and then it's going to have 2 kinds of accounts below it. So there'll be bank account, and then there'll just be a savings and a checking account. And we'll say that a savings account is a bank account and a checking account is a bank account. Okay, so now we can turn this into code in not too bad of a way. So here's what it will look like when we turn this example. We're going to combine these. Well, we're not going to combine these two. We're going to essentially, the way we rephrase it is it's like algebra. We're going to factor out the part that's common and put it outside of these two, but then tie them to it. So it's a little bit kind of like doing algebra. And we actually use the word factor out. We're going to say that we can factor out what's redundant or common in here and in here into a bank account class, and then savings account and checking account will be bank account class. Okay, so now here's what this looks like is code. Okay, here's what it will look like in code. Here's the bank account class. It's got the core stuff in it. So it's got what was redundant in the two other accounts before. So a bank account has a balance. You can deposit and you can withdraw from it. Okay. Then here's the whole point of the chapter. Savings account extends bank account. So a savings account inherits this stuff here. Notice this stuff here is not inside here, but it is now. By using this word extends bank account, the savings account, any savings account object has all this stuff in it, along with this stuff here. So a savings account object, what's in it? An interest rate and a balance. There's a compound interest method and a deposit method. Now you have to look at both of these to see that. So you mentally combine these two classes together to get what a savings account is. And then what's a checking account? Well, checking account, see, extends bank account. Oh, and notice that extends is a nice word for that because you can, the picture, you say savings account extends bank account. So in this kind of a picture here, you can kind of think of it as, the savings account is an extension of the bank account. We kind of draw it visually that way. So the word they use is extends. They could have used other words, like you could have said checking account inherits bank account, because we call this, remember the chapter is called inheritance. So, some people may have designed the language to say checking account inherits bank account. Okay. But most programming languages like this word extends. Okay. They say that a checking account extends a bank account. Okay. So then by the magic of the Java programming language, a checking account isn't just this. A checking account is that along with everything up here. Now, if you forget this, now a checking account just is something that has no data in it and it can only write a check, but this won't work very well because you can't write a check against anything. There's no data for it to work with. Okay. So it's important when you do inheritance, when you design these class hierarchies like this, that you draw it like you remember that the extends keyword. Now, this is one simple example, and we'll play around with it a little bit more in a second, but let me show you. Here's a picture from another book. Here's some other Here's some other examples of inheritance. Okay, so like one we'll look at a little bit later today is shape. A circle is a shape. A triangle is a shape. A rectangle is a shape. A sphere and a cube are both shapes. So we call the thing at the top the superclass, and we call the things below subclasses. So in that picture from the book, vehicle is the superclass, and motorcycle, car, and truck are the subclasses. But also in this picture, car is a superclass to sedan and SUV. So car is both a subclass of vehicle and a superclass of sedan and SUV. remember I said many times, we have words for everything, and we keep using these words. We have words to describe all these kinds of relationships. So motorcycle is a subclass of vehicle. Vehicle is a superclass of motorcycle. Sedan is a subclass of car. We also say the sedan is a subclass of vehicle. So sedan is a subclass of car and sedan is a subclass of vehicle. Car is a subclass of vehicle and car is a superclass of sedan and a superclass of SUV. Okay. And so here, shape is a superclass of circle, triangle, rectangle. Like here's bank account. See, from this book, a bank account has two subclasses, checking account and savings account. A bank might go further and say we have different kinds of loans. So they might have a loan superclass. And then there's car loan, home improvement loan, mortgage loan. Those, the idea would be that if you had to describe a car loan, there'd be a bunch of things in it. And if you had to describe a home improvement loan in code, there'd be a lot of things in the home improvement loan that were also in the car loan. And you don't want to have to keep writing that code over and over again. So you don't want to have a car loan class, a home improvement class, and a mortgage loan class, and then look at them and say, but I wrote the same code over and over again. So then you factor out what's common into loan, and then you say car loan extends loan, home improvement loan extends loan, mortgage loan. In the code, you write actually at the beginning of the class, you'd say class mortgage loan extends loan. Okay, and like here, you would class circle extends shape, class triangle extends shape. So if somebody just said, write me a circle class, a triangle class, a rectangle class, and a sphere class, you could do it using what's in the last chapter, but you would end up putting a lot of stuff in these classes that was duplicated. So when people first invented object-oriented programming, they saw that and they had this idea that we should be able to lump classes into categories. Okay, so we should be able to take circle, triangle, rectangle, sphere, and cube and lump them into a shape category. Okay, and then we can write code that's common to all of them once, and then write code that's unique to circle once, unique to triangle once. Okay, okay. So like here's another picture of the idea of a shape class. Okay. So here someone drew, this is from another book, but here's a picture where somebody said, well, a shape could be a two-dimensional shape or a three-dimensional shape. So two-dimensional shape is a subclass of shape and three-dimensional shape is a subclass of shape. And then a two-dimensional shape, then here's where the circle, square, triangle is. So notice that when people design these hierarchies, these class hierarchies or inheritance, there's a lot of room for different ideas. So here somebody's shape breaks down into two-dimensional and three-dimensional. Then the two-dimensional shapes are circle, square, triangle. The three-dimensional shapes are sphere, cube, tetrahedron. Here's another example of somebody designing a shape. Okay, whoops. Okay, this one's I think I can fit them all in. Okay, so here's somebody did something a little bit different. So a shape can be a rectangle, a triangle, or an ellipse. Okay, now notice they didn't put circle under shape, they put ellipse under shape because a circle is a ellipse where the major axis and the minor axis are the same. Similarly, a square is a rectangle where the lengths of the sides are the same. So here they did shape, but like here someone did shape with multiple levels, but distinguished between two-dimensional shape and three-dimensional shape. Then they just did circle, square, triangle. And here somebody say, oh no, well, I could think about it a different way. I can make shape have rectangle, triangles, ellipse. Okay, these are all two-dimensional shapes, but then say, okay, a square is a rectangle, a circle is an ellipse. Now, when somebody writes the code for this, they'll say square extends rectangle, rectangle extends shape. Okay, so you'd have a class shape with whatever you think is common to all of these shapes, and then you put into the rectangle class just what it needs, and class rectangle extends shape. You don't say class rectangle extends class shape, you just say class rectangle extends shape. Okay, so these are the kind of ideas we're going to play around with. Some of these examples are easily translatable into code, and some aren't. Like most of these examples are pretty easy to translate into code. These two The one the book starts with this picture, it's a nice picture, but it's a little bit hard. Like he doesn't do a code example of this. He does not give you an example of what a vehicle class would look like and a motorcycle class and a car class because it's a little bit too, yeah. We obviously know a motorcycle is a vehicle and a motorcycle is different than a car. But if I ask you to like, okay, make that into classes in Java, I'm not sure I would even know how to do it. Like I wouldn't know what to put in a truck class that's not in a car class to make it a, trucks just look different to us. Yeah, and they have bigger engines and they can haul more stuff and they're just larger, but you that doesn't lend itself very well to programming. So this gets across the idea of a car is a vehicle and a sedan is a car, but it doesn't lend itself to writing code. These other examples do. We'll see that, these are examples we'll use. Student can be a grad student or an undergraduate student. A shape can be a circle, triangle, rectangle. A bank account. We've already did that one. We saw that you could do bank account as a checking account and as a savings account. Yeah. So these examples kind of lend themselves to code a little bit better than some examples lend themselves to code better than others. Okay. So if you look in other books and as you read, you'll see lots of examples that maybe you just work in words, but don't work so well when you actually try to write them as code. Okay. Now let's go back to this example. Okay. Now remember, what we did was we took what was common to these guys. There's the shaded part is the common part. Okay. So what's common to those two, oops, what's common to those two ended up becoming part of the bank account. That's the super class. Okay. And then we can say, okay, a savings account is a special kind of bank account, and a checking account is a special kind of bank account. The savings account needs an interest rate, and you need to be able to add the interest into the account once a month or so. Okay. The checking account, it needs a way to write a check on it. Okay. So remember, they inherit everything that's in here. Now, down here, I got a little bit of code, just 2 lines of code. I'm going to create a savings account object and a checking account object. And this is where things get, in the long run, really abstract. Notice that my variables that are the references are bank account reference variables. Okay. So I have a bank account reference variable and I pointed at a savings account. And I can do that because a savings account is a bank account. And I have another bank account variable and I point it at a checking account object. Okay? And so this is one, okay, well, we're, this idea that the reference variable can be different type than the thing it refers to is what makes make this stuff tricky. Okay. And as we go along, we'll see what I mean by that. But that right now I have the reference variable is not exactly the same thing as the thing it's pointing at. It's a bank account reference variable pointing at a savings account object. We've never seen anything like that really before. We always had, whatever the object, whatever the reference was, whatever it pointed at was the same thing as the reference. Now, if I visualize this, okay, here you can see there's a savings account object. Notice how the savings account object has the interest rate and a balance, but the checking account object only has the balance. Remember, the balance was from bank account. Notice you don't see that in the picture. Okay. When you see like this object is a savings account object. It's made of stuff from bank account and stuff from savings account. When the code is running, they are actually combined together. Yeah, the savings account object really is kind of bundled up with the bank account object in one object, and you see all the stuff is there. On the other hand, the checking account doesn't have any new data. So the only data in the checking account is what it inherited from the bank account. Okay. But notice that if you go down here and you just look at this code here, you would wonder, where the heck did this come from? See, because there's no balance in checking account. But then you have to remember, oh, it says extends bank account. So checking account extends bank account. Go up here, bank account has a balance. That's where this guy came from. So that's the balance in the bank account part of the checking account object. Okay? This is also the balance of the bank account part of the savings account object. Okay. And then it doesn't say it over here, but this is a bank account reference variable, and this is a bank account reference variable. Okay. Now, I can do a little bit more. Let me play around with this a little bit. If I want to, I can create a savings account reference variable. So there's a savings account reference variable, and I can point it at a new savings account. So now I'm going to have two savings accounts, and I can create. Now, here's what I can't do. I'm going to do something that's a mistake. I'm going to create a savings account reference variable 2 and try to point it at a checking account. Okay. So now I want, notice that the bank account variable didn't, bank account didn't agree with checking account, and bank account didn't agree with savings account. Here I have savings account, savings account. Well, what if I have savings account here and checking account here? And Java's going to complain. Okay. Incompatible types. If we go back to our drawing, a checking account is not a savings account. If you go over here, a checking account is a bank account. A checking account isn't a savings account. There's no relationship going horizontally between checking and savings. So over here, a savings account is a bank account. So you can write that line of code. A checking account is a bank account. So you can write that line of code. A savings account is a savings account. But a checking account does not have the property that a checking account is a savings account, so you can't write this. You can't just mix these things up. In terms of a picture, we go back over here. Where's the book? Oh. If I have a reference variable that's a car reference variable, I can ask, what kind of objects can it point at? A car reference variable. Now, this is one of the reasons why I've always said you have to make sure you really distinguish between reference variables and objects. This is where it starts becoming really important. Reference variables have their own rules and objects have their own rules. And we're going to really make a distinction from now on between a reference variable and an object. So if I have a car reference variable, maybe I can even just go over here and I'll just type in some fake code over here. So I have a car reference variable. Now I'll call it car1. What can it point at? What kind of object? Well, car should be okay. A car reference variable should be able to point at a car object. Okay. So our picture looks like this over here. We're going to try to think about what code we can write. What are the rules? Okay, a car reference variable can point at a car object. That doesn't look unusual. A car reference variable can point at a new sedan because the sedan is a car, and a car reference variable can point at a new SUV because an SUV is a car. But you can't go the other way around. You can't have a car reference variable be a new vehicle. This would give you a compiler error. Okay. Similarly, if you did a car reference variable is a new truck. Well, a truck isn't a car. You can't have a car reference variable point at the truck. So a car reference variable can point at itself or its subclasses. Okay. Now, a vehicle reference variable, what can it point at? Well, it can point at a new vehicle, whatever that means. Okay. And it can point at anything. Everything is a vehicle. So this could be a new SUV. You could say vehicle V2 is a new SUV. Now I can't compile these and show you that which ones to give you error messages and which ones don't, because I haven't turned this into code. But the idea is that anything, yeah, a reference variable from a tree like this can point at objects anywhere that's below it in the tree. Okay, so I can point that at a new vehicle or okay, vehicle V2 equals new motorcycle. Okay, now truck T1 equals truck can only point at a truck reference variable can only point at a new truck object because there's no subclasses of truck. You can't have a reference variable point up. I can't have a truck reference variable point at a vehicle object. The rule is a reference variable can point to any object that comes from below it in the tree. Okay, so vehicle can point to objects of any of these kinds. Car can point to any of these. Motorcycle can only point to a motorcycle, and a truck can only point to a truck. Okay. Okay. So that's kind of the mechanics of this, and it makes sense that a motorcycle is a vehicle, but a truck is not a car. So that one's wrong. Okay. Let's see, was it? Okay. So that one, you can't have a a reference variable from over here point at an object from over here. You can't go horizontally. Okay. You can't have a car reference variable point at a truck object. Okay. Now it gets a little bit trickier than that. Let's go back to the bank account example. Let me find it. Okay, so this one doesn't work. So I will make this a, I can make this a, okay, so I can have a checking account. This will work because a checking account is a checking account. Okay. Okay. So I have, now the visualizer doesn't show you it over here, but that's a bank account reference, a bank account reference, a savings account reference, and a checking account reference. It does tell you over here, this is a savings account object. This is a checking account object. This is a savings account object. And this is a checking account object. Okay, so it tells you the type of the objects. It doesn't remind you of what the type of the reference variables are. Okay, and you always have to obey the rule that the reference variable has to be above the object in the tree you're drawing. Okay, now on a savings account object, I can call compound interest. Okay, and on a checking account object, I can call write check. Okay. Now, if these don't do anything, notice that the compound interest doesn't even have anything in it, but I can still call it. The compiler will let me do this, but it's just if I execute this, it doesn't do anything. Similarly with write check, I can write this. If I, oops, what did I do wrong? Oh, write check needs an amount and a check number. So I'm going to write in a check for $10 on check 1001. Okay. Okay. See, I could, I could create these objects and I could call those methods. Now, here's where things get a little bit tricky. Take bank account 1. It's a savings account. Can I compound the interest in it? Okay. And bank account 2 is a checking account. Can I make a deposit? Can I write a check on it? Okay, I'll write a check for $20 and it'll be check 1002. Okay. The answer is no, this isn't going to work. This isn't going to compile. Okay. Now, why would that be? This is where things get tricky. I can compound interest, that worked, but it didn't work down here. Okay. And if I comment out that line, because that it didn't like that line, it's not going to like the line below it either. See, it's not going to like that line either. But I can write a check here, so why can't I write a check here? Okay. And the answer's one of the deep issues about how Java and JavaScript and C++ and Python, how they do object-oriented programming. Okay. From the point of view down here, from the point of view of Java, this guy really isn't a savings account. It really is a bank account. And a bank account doesn't know about compounding interest because, see, that method is not in bank account. Similarly, this guy is really, from the point of view of Java, a bank account. It's not really, from the point of view of Java, a checking account. If you go down here, that's a banking account reference. Bank accounts don't know how to compound interest. That's a banking account reference. Banking accounts don't know how to write checks. Only checking accounts know how to write checks, and savings accounts know how to compound interest. So the way the rules work, if we go back to this picture here, if you have a car reference variable, you can call car methods on it. But if the car reference variable points at an SUV, you can't call SUV methods on the car reference variable. Okay. So it's a little bit tricky. It's going to take a little while to get used to it. But if now remember, the distinctions between the reference variable and the object. Okay. If you have a car reference variable, suppose it's pointing at an SUV object, the car reference variable, you can still only call car methods on it. You can't call any of the SUV methods because your reference variable is a car. Okay. Like over here, on these reference variables, I can only call car methods. I can't call sedan. I cannot call a sedan method on that reference variable. Java will tell me that a car doesn't know how to do that. I can't call an SUV, whatever an SUV method would look like. That's why I say it's kind of hard to turn some of these examples into code. But since this is a car reference variable, you can't use it like an SUV. You can only use it as a car. You can't use this car reference. Well, this car reference variable doesn't work. You can't point at a truck. Okay. Now, this vehicle reference variable is an SUV. Again, you can only use vehicle methods on it, which would be the methods that would come from way up at the top of the picture. Okay. If you have a vehicle reference variable, the only methods you could call on V2 would be the methods in here. Even though the vehicle reference variable is pointing at an SUV object, you can't call any car methods, you can't call any SUV methods on that reference variable. Okay, you're kind of limited by what the reference variable is, as opposed to what the object is. Now, as we go farther in this, we'll see that there's going to be a lot of rules about when you have when you mix up when you have a reference variable of one type pointing at an object of a subtype, we're going to see there's lots of rules about this kind of stuff. You know, right now, we're seeing one rule, and we'll see others. The rule we're learning right now is that on a reference variable of the supertype, you can only call methods from the supertype. even if that reference variable points at a subtype, you can't call methods from the subtype. So a reference variable type vehicle can only call vehicle methods. Even if the reference variable is pointing at an SUV object, you can't call any of the SUV methods. But we're going to see as we go along that that's in different places of Java, there's different rules. Sometimes it's the type of the reference variable that's more important. Sometimes it's the type of the object that's more important. So the reference variable has one type. In this case, the reference variable is bank account. The object has a different type. In this case, the type is savings account. Sometimes in that relationship, it's this side that's more important. Sometimes it's this type that's more important. And when you call a method, it's this side of the arrow that's more important. If you have this arrow from a reference variable to an object, you can only call methods that are in the type of the reference variable. Okay. And if you go back to this picture, if you have a car reference variable, you can call vehicle methods and car methods. But if that car reference variable points at an SUV, that car reference variable you can only call SUV methods. Okay. A car is a vehicle. So in a car reference variable, you can call vehicle methods and car methods. But if the car reference variable points at a sedan object, on that car reference variable, you can't call sedan methods. Okay. And it gets tricky. Yeah. And this lends itself to lots of easy problems on exams where you give somebody a picture like that, and then you write a piece of code like this and say, what methods can I call on car 3 on that reference variable? What methods can I call on that reference variable? What methods can I call on that reference variable? The answer here would be on this reference variable, you can call any method that's in car or vehicle. It came from this picture. You could, on car 3, that reference variable, you can call any method from vehicle, you can call any method from car. But even though car 3 points at an SUV, on car 3, you can't call SUV methods. Okay. All right, so let's keep playing. Let's try to go back and forth between these ideas and some examples in code. Okay. So again, I couldn't do this. Now I can cheat. This is usually not considered a good thing to do, but I can do the following. I can tell Java that this guy is actually pointing at this is called a cast. What I'm going to do is I'm going to tell Java that BA1, which is a bank account, really is a savings account. And then I have to put another pair of parentheses. Okay, what I'm doing now is I'm telling Java, see this bank account reference variable. It's a bank account reference variable. This is my way of saying it really points at a savings account object. So now you can call that method on that object. But notice I needed a couple, that's a weird way to write. It's a weird thing to do. It's usually considered a bad idea to write code like this, but you can tell Java that this thing really points at that kind of thing. And over here, then I can do the same kind of thing. I can say that this bank account is really a checking account. And now Java will let me recall the right check on it. See, Java was happy now. Okay, so even though that's a bank account reference variable, I can do what's called, I can cast it to what it actually points at, but I have to know what it points at. But if I do know what it points at, I can cast it to say to Java, this bank account reference variable really is pointing at a savings account object, so go ahead and call compound interest on it. And this bank account reference variable really is a checking account object, so go ahead and call write check on it. Okay. But without those casts, we could go ahead and put it back the way it was. Okay, so again, this doesn't work. This is wrong. And this other one is wrong too. Okay, and Java will verify that for us because bank account doesn't know about compounding interest. Bank accounts don't have compound interest in them. Okay, so that one doesn't work. And this one doesn't work because a bank account doesn't know about writing checks. There's nothing in bank account about writing checks. So on this reference variable, you're not allowed to call write check, but you can sneak by that with this kind of thing here by saying, well, this bank account really is a checking account. So you can write a check on it. Okay. We learn these this is something you shouldn't actually do. If somebody writes code like that in the real world, usually you'll be told that's really bad idea. You shouldn't be writing that. You really should be rewriting your code a different way. Java lets you do this, but it's considered a really bad thing to be doing, to have a reference variable of one type. You convert it essentially to being a reference variable of a different type, and then you call a method that you didn't think that the Java wouldn't let you call directly. Okay. But the idea here is that the type of this guy is not the same as the type, well, the type of this reference variable is not the same as the type of the object. That's what makes this interesting. And we'll see. You might say, well, if this doesn't, if, why even allow this? If it can cause kinds of problems, we'll see what we want to do with it. We'll see as we go along why we would want the reference variable to be different than the object it points at. And it's always going to be the reference variable comes from higher in the tree and the object comes from lower in the tree. Okay. Now, let's look at another example a little bit. Let's play around with this. Okay, here's the shape example that we saw a picture of. Here, I'm going to turn the shape example into code. So here's what I think would be every shape could do. Every shape should be able to tell you what its area is and what its perimeter is. Doesn't matter what the shape is. You'd think that, okay, a shape covers a certain area and it has a certain perimeter. Now notice that I just returned 0 here because there's something very abstract about shape. I don't know how to compute the area of a general shape. There's no way that you can compute the area of any shape. So the get area method is just going to return 0. Essentially, what I'm doing here is I'm saying that every shape knows how to compute its area and every shape knows how to compute its perimeter. Now, if you give me a specific shape, like, okay, a circle is a shape. The circle knows how to compute its area, pi times the radius squared, and a circle knows how to compute its perimeter, 2 pi r. Okay. And notice that a circle needs to know some data about itself. So this is the coordinates of the center of the circle, and that's its radius. Okay, notice that data is new. It's not in shape. Notice that the shape doesn't hold any data, because I don't really know what information you need to describe a general shape. So if we go back to if we think in terms of this picture, not that one. Yeah, this shape, this superclass shape is very abstract. Yeah. What information does it hold? I don't know. I don't know how to describe an abstract shape. What I do think is true about anything that I call a shape would be, oh, it knows what its area is and it knows what its perimeter is. These specific, what we sometimes call concrete shapes, they should know how to compute their area and their perimeter. So then let's look here. Like here's rectangle. Okay, now a rectangle would be, this is going to be the upper left-hand corner. So the XY represents the upper left-hand corner of the rectangle. Then it's got a width and a height. Then it's got a width and a height. So here's the data in a rectangle. Completely different than the data in a circle. There's no data in a shape, but Oh, and see how I use this word override here with this funny little at sign in front of it. This is something we haven't used before. It's called an annotation. It tells Java that this get area replaces that get area. That when you have a circle and you call get area on the circle, it's going to call this get area, not that get area. Okay. So this is sort of a dummy thing here. It just says shapes should know how to compute area and shapes should know how to compute perimeter. And this guy just does the really kind of dumbest thing possible, just returns 0 for the area and returns 0 for the shape. So it's not really computing an area perimeter, but it's basically saying that any shape you define should know how to do these two things. So circle does it one way, square, rectangle does it a different way. Rectangle, the area of a rectangle is width times height. The perimeter of a rectangle is 2 times the width plus 2 times the height. Okay, now, the other thing is I have a triangle. Now, I just, I didn't want to write out the complicated formula for the area of a triangle and the perimeter of a triangle. It's unfortunately a square and a circle and a rectangle have an easy formula for area and perimeter. Triangles actually have a fairly complicated one. The triangle's 3 points. There's the XY coordinates of one corner. There's the XY coordinates of another corner. There's the XY coordinates of another corner. So a triangle is described by 3 points. A rectangle is described by 1 point and a width and a height. A circle is described by 1 point and a radius. Okay? The triangle, I mean, if I wanted to, I could write out the complicated formula. It's a really pretty complicated one, but I could write out the formula in terms of these numbers for the area of a triangle, and I could write out the formula using those numbers for the perimeter of a triangle, but it wouldn't be worth it. Okay. Okay. So this is an example of an inheritance. Okay. The shape, what's common to all, notice that what would, if I didn't use inheritance, actually, there's a real difference here between this one and the bank account one. And this is actually one of the subtle aspects of this. See, this code here actually got reused by savings account and checking account. I didn't have to redo deposit and withdrawal. That's kind of a nice feature of this bank account class. Over here, I don't get that code reuse. The shape class does not know how to get area and perimeter. Okay. I have to write it out for the circle, and I have to write it out for the rectangle. That's very different than over here. Savings account got deposit and withdrawal for free without rewriting it because it's just this, depositing into account doesn't matter if it's a savings account or a checking account. So this is one kind of inheritance. This is an inheritance where these guys get to reuse code from their parent class, their superclass. This is another kind of inheritance. This is the one that uses this override. This is the kind of inheritance that says a circle knows better how to compute area than shape does. So circle says, here's how I compute area. And then rectangle says, here's how I compute area. But I have to retype I have to define the code here. I have to define it here. So here, I did not redefine these things. Here I am. So there's all kinds of ways that we use inheritance. And sometimes it's more bank account like, where what I put up here doesn't need to be duplicated down here. That's a nice thing. Sometimes it's more like this, where what's up here needs to be duplicated down here because this guy doesn't know how to do that. But I want that there because I want to say that every shape must know how to get its area and every shape must know how to compute its perimeter. This is a way of saying that all shapes know how to do this, but they have to know how to do it the right way. Circle needs to know how to do it its way. Rectangle knows how to do it its way. Now notice down here, I have 3 reference variables. Okay. Now, can I do s1.getArea? The answer is yes. And what's it going to do though? S1 is a shape reference variable. There's a get area method up here. It's not going to return 0. Let's actually let's do some changes here. Okay, S1 dot X, make it, well, let's give this one a radius. S1 dot radius equals 4. Okay, we'll see that there's no constructors. I didn't give these guys constructors. Remember, if I don't give them constructors, I get for free a default constructor. This will be 0, this will be 0, this will be 0. Again, there's no constructor here, so I will get a default constructor. This will be 0, this will be 0, this will be 0, this will be 0. Okay, so here's my circle object, and I give it a radius of 4. And then I'll give my rectangle a width of 2 and a height of 3. So I can do then area 1 is S1 dot get area. Area 2 equals S2 dot get area. Okay, now here's where things get a little bit tricky and kind of not really obvious what's going to happen here. This is a shape reference variable. Call get area on it. Get area says, okay, a shape gets its area by returning 0. But this guy is really a circle object. And here's where these funny rules come in. When it comes time to compute the area, even though that's a shape reference variable, it'd be dumb to compute area this way, so Java will compute area this way. It'll call the method in the object, not the method in the reference variable. Okay, so it's a shape reference variable pointing at a circle object. When I call get area, it doesn't call the get area method in the shape class. It calls the get area method in the circle class. Then down here, I'm calling get area, but this is a shape reference variable. This is a shape reference variable, but it's actually pointing at a rectangle object. This get area calls that one, not the one in shape. This is actually a fancy word. This is something called polymorphism. Poly means many. Morphism, the word morph means to change. What this is saying is that this thing's kind of shifting around underneath you in a funny way. There's 3 get areas. The one in shape, the one in circle, the one in rectangle. Which one is this? The rule in Java is it's polymorphic. You don't call the get area on this type. You call the get area on the type that this thing actually points at, which was circle. So this is the get area in circle. This is polymorphic. Of the 3 get areas, which one is this? Well, it's not the get area that would be in the shape class, since that reference variable points at a rectangle object. Whoops, my rectangles were S3. So I have to make these S3. You get the area method that's in the object pointed at by the reference variable. Okay, so that's different than the rules for naming. When we were over here, we had rules for naming. When I had this reference variable, what method could I call? Only the methods in the reference variable, not the methods that are in the object, the methods that are in the reference variable. Over here, when I do call a method, which one does it actually call? That method is in the reference variable, but it doesn't call that one. It calls the method in the object. That trick is called polymorphism. So if I visualize this, whoops. let's see, what's it complaining about? Cannot find symbol, variable R, location, S1. Oh, see, now I can't, yeah. Now this is where my rule from back here kicks in. S1 is a shape. Shapes don't have X, Y, Z, X, Y, and R. So now I have to play that game of doing this cast. I have to say, well, I really know that this guy is a circle. So I'm telling Java, he's really a circle, so it's okay for me to give him a radius. Similarly, this one really is a rectangle. So it's really okay to put a width in there because it's a shape reference variable. Shape reference variables don't know anything about X, Y, R, width, and height. So Java's not going to let me put R into a shape reference variable. So I have to say, well, it's really pointing at a circle. This guy's really pointing at a rectangle. Let me do the same thing here. Okay. This is really pointing at a rectangle, so you can give it a height. But then down here, I don't have to do the cast. This is a shape reference variable, but I'm actually going to call area on the circle. And this is a shape reference variable, and I'm going to call the area on the rectangle. Oh, now what did I do wrong? What am I? Oh. Not easy to talk and type at the same time. Okay, so notice that it compiled. Java was happy with my playing around here. A shape reference variable does not know about radiuses. The shape reference variable doesn't know about radius, but it's really a circle. So I tell Java it's really a circle, so I can give it a radius. Now, let's step through this, and we'll see that when we get down to here, we'll actually just run it. Notice that I didn't get back area 0 or area 0. So it clearly did not compute. It didn't compute this area because I'm calling get area on a shape reference variable, but clearly I didn't call the do nothing shape area method. I called those ones. Okay. So let's step through it and watch what happens. Okay. So I create a circle reference variable. I create a shape reference variable. And I have to then call a constructor. Right now I'm calling the default constructor, which really isn't there. But see, notice how actually let's go back to the beginning. We're going to call the circle. We're going to build a circle object. We're going to create a shape reference variable and build a circle object. So what does Java do? Okay, it starts calling a circle constructor. Okay, so we are in the circle constructor, but the circle is a shape. So we detour to the shape constructor. The shape constructor really doesn't do anything for us. Then we go back to the circle constructor. The circle constructor gets to finish its work, which isn't really doing, it's just the default constructor, so it's just going to make everything 0. But notice how when you're building a circle object, you have to make a detour up here to build a, when we do more complicated examples, we'll see that these could do different things, but to build a circle object, you have to jump up here and build a shape object, then go back down here and continue building a circle object, okay? Now I'm going to build a triangle object. So I'm up here, I'm building a triangle object. I need to detour up to the shape class and build a shape object, and then essentially finish the shape object into a triangle object. Okay, so now I have a triangle object. Similarly, I'm going to build a rectangle object. So I start building a rectangle object, but I have to detour to let the shape part build itself. Then I complete the rectangle part, and now I have a rectangle object. Okay, so there's my three objects. Now I can set the radius in S1. See, I set the radius. Now, again, I had to do that carefully. That's a shape reference variable. I got to tell Java it's really pointing at a circle object. So even though this is a shape reference variable, on the other end of the arrow, there is an R. That's what this is basically saying, that I'm promising you that at the other end of your arrow, there's really an R. And this is promising Java at the other end of this arrow, even though it's a shape reference variable, at the other end of the arrow, there really is a width. Okay, so we can, okay, so now the rectangle has width. Now here's the interesting part. S1 shape reference variable, call get area. Okay, there's three get areas up here. There's this one, and this one. Now, this is the one in rectangle. We're dealing with what we know is a circle object. We know that that thing really points at a circle object, but that still doesn't tell us if it should call this get area or this get area. The reference variable is shape, the object is circle. Java does the right thing. Java calls the get area on the circle. So when we call this, see, we're in circle. We're in get area inside circle. So Java figured out in this case what's the right thing is. Okay. And similarly, when we go here, even though this is still a shape reference variable, but now this pointing at a rectangle object, when we call this get area, we get area in the rectangle. We don't need to do this stuff here. Java now figures out that even though this is a shape reference variable, it'll call get area in the rectangle object. Okay. This is the kind of trickiness that we need to learn a lot more about. We're going to keep doing examples like this, and we'll play around with these and build up a sense of what the rules are for these. Okay, the rules are not trivial. Okay, and they're kind of abstract. You have reference variables of one type pointing at objects of a related but different type. So you could have reference variables of type vehicle pointing it to an object of type SUV. And there becomes all kinds of, well, which methods can I call? Which methods will be called? Which methods can I actually write the name for, and which ones will actually be called? Okay. So we're going to keep playing around with these and learn all these different rules. The rules are not easy. Okay, inheritance and polymorphism. You get a kind of a hint when you get a word like polymorphism. Yeah, that you get kind of the hint that that's not going to be a simple idea. And in the book, see, polymorphisms actually, what we just did was a little hint of it. It's actually the reading for, if you go back to the class, that section 9.5 is the reading for next week. So we've already seen a little bit of hint of what this polymorphism idea is. So we'll be talking about this more on Thursday, and then we'll be talking about it more next week again. So we've already kind of crept a little bit into this section here on polymorphism, but in a real simple example, and we'll do it more complicated examples when we get to section 9.5. The thing to always keep in mind is now we have this real important distinction: the type of the reference variable and the type of the object. When you draw an arrow, there's a reference variable on one end and an object on the other end. The reference variable has a type, the object has a type. They don't have to be the same. They have to be related to each other by one of these trees. They have to be related by a tree, but they don't have to be the same. And there's fairly complicated rules about how this works when the type of the reference variable and the type of the object are related, but not the same. Okay? Okay, and okay, we've gone an hour and 15 minutes, so it's the end of the class at this point. Nobody's said anything. I hope I don't know if anybody had any questions or not. So what we'll do now is I'm going to keep this meeting open. I'm not going to close it or anything. I'll just leave it open, but I'll make the lab available, and you just go to the course website. Yeah, and the lab will be there in a minute or two, and you can start doing the lab. And as you're doing the lab, if you have any questions, I mean, like I say, I'll be here in this meeting. I think it'll work. I can just stay in this meeting, and if somebody has any question, if you don't want to leave the meeting, you don't have to leave the meeting. If you want to rejoin the meeting, if you want to leave, you can rejoin. But if you have a question while you're doing that, probably we'll see is probably have you share your screen. I may have to turn that on, but when you have a question, probably what we'll do is I know that when I have office hours with Zoom, I always do it that I have people who have a question share their screen. So, if you can share your screen through Zoom, and then I can see what your code looks like, and we can talk about your code. So I think that'll be what we can do is that I probably have to turn on screen sharing, but if you have a question, you can either, if it's a simple question, you can just ask me the question by words, but if you need to show me your code, you can do it by screen sharing. Okay. So again, if you want to take a break, if you want to leave for a little while, we're done here. I'm going to put the lab up on the course website in another minute or so. And then, from the rest, for the rest of the next couple hours, if anybody's got any questions, just, comment and ask me. Let me make the change here. Okay, now if you refresh your screen, there's the lab. Okay. I don't have the code examples that we just did. I'll put them up in a link in a little while, but there's the lab. It actually won't open for 3 more minutes. So it'll be a couple more minutes before the lab itself actually opens. Okay. Anybody got a question? Anybody want to say anything or bring up anything? Okay. So like I say, I'll stay here. And if anybody's got a question, just uh, raise your voice, unmute yourself, raise your voice and ask. Okay. All right.